So let's see an example. We have that 10 randomly selected people were asked how long they slept at night. The mean time was 7.1 hours and the sample standard deviation was 0.78 hours. Find the 95% confidence interval of the mean time. And the variable is normally distribution. Usually here, for estimating a mean, we need that the variable in this case is time in hours, time people sleep at night in hours. That's a continuous variable. And we're gonna assume that it has the normal distribution. So if this is a problem in the test, you will not have this information that this is about the population mean. So you will have a problem like this. How do you know if this is a problem involving proportion or a problem involving the mean? Well, because of the keywords, it says find the confidence interval of the mean time. So this is telling us that we need to use the formulas corresponding to the mean. If it says find the confidence interval of the proportion, then you need to use the formulas for proportions. So in this case, we want to find a 95% confidence interval for the mean time that people sleep at night. So the confidence interval will be the sample mean minus the margin of error, comma, the sample mean plus the margin of error. So what's the sample mean? This will be given, but you need to know what's the value. When you read the problem, what's the mean of the sample? It's 7.1. So the sample mean is 7.1. So that's the value that we use here. We're going to subtract 7.1 minus the margin of error, and we're going to add 7.1 plus the margin of error. So now we need to find the margin of error, which is the critical value t times the standard deviation s divided by the square root of n. The standard deviation, what's the value of s? 0.78. What's the sample size? The value of n. How many people are in the sample? 10. This is n. This is the sample mean, and this is the sample standard deviation. So now we need the value of t. To find t, we need the confidence level. What's the confidence level? 95%. And what will be the degrees of freedom? The value of df? 9. df is always n minus 1. So 10 minus 1, 9. So using 95% and 9, we can find the value of t in the body of table F. It's here. And then df equals 9 is here. So what will be the critical value that we're going to use in the formula for the margin of error? 2.262. So the critical value t is 2.262. So now we have everything that we need to find the margin of error. This will be 2.262 times the standard deviation, 0.78, divided by the square root of n, so the square root of 10. So use your calculator and round to 4 decimals. What's the margin of error? So the margin of error, rounded to 4 decimals, is 0.5579. So what will be the confidence interval? What will be the lower limit? The lower limit is the sample mean minus the margin of error. So 7.1 minus 0.5579. And this is equal to what? Let's round it to 1 decimal. Usually we're going to round to the same number of decimals that the sample mean. So if the sample mean has 1 decimal, we're going to round the limits of the interval to 1 decimal. So 7.1 minus 0.5579 is 6.54, but if we round it to 1 decimal, it's 6.5. And then the upper limit will be the sample mean plus the margin of error. So 7.1 plus 0.5579. So what's 7.1 plus 0.5579 and rounded to 1 decimal? 7 point what? 7.7. So what's the final answer? What's the confidence interval? Is the interval from 6.5 to 7.7. And remember that another notation will be the mean mu between 6.5 and 7.7. That's another way to write a confidence interval. So we have the solution here in the next slide. The margin of error that we obtained was 0.5579 using the critical value T 2.262. The lower limit of the interval is 7.1 minus the margin of error. So we round to the same number of decimals used for the sample mean, so 1 decimal, 6.5, and 7.7. And we can interpret by saying that we are 95% confident that the interval from 6.5 to 7.7 does contain the population mean. You can also say that the probability that the mean is between 6.5 and 7.7 is 0.95. Because the confidence level is 95%, the probability will be 0.95. Now, let's do this example. A survey of 30 adults found that the mean age of a person's primary vehicle is 5.6 years, and the standard deviation is 0.8. Find the best point estimate of the population mean. Find the margin of error corresponding to a 99% confidence level, and then find the 99% confidence interval of the population mean. So, what would be the best point estimate for the population mean? It's always the sample mean, but what's the sample mean in this example? What's the value of X bar, the value of sample mean? 5.6. This is the sample mean. It says that the mean age of a person's primary vehicle is 5.6. So the sample mean is always the best point estimate of the population mean. So this will be the answer for part A. So the formula for the margin of error when estimating a mean is the critical value T times the standard deviation divided by the square root of n. So what's the standard deviation? What's the value of S in this example? 0.8. And what's the value of n? What's the sample size? 30. So we have S, we have n, so we need to find T using the confidence level. What's the confidence level? 99%. Okay, so remember in table F, you need to use the correct number for degrees of freedom, for DF. And DF is n minus 1. So this is the formula that we need to use. So we have to find the correct value for T. So to find T, we use the confidence level, 99%, and the degrees of freedom, n minus 1. So n is 30. 30 minus 1 is 29. So we need to use table F to find the value of T corresponding to a 99% confidence level and 29 degrees of freedom. So 29 is here and 99% is here. So what's the critical value that you need to use? 2.756. Very good. So this is the critical value. T will be 2.75. Now we have everything to find the margin of error. So 2.756 times the standard deviation is 0.8 divided by the square root of 30. When you use your calculator, you should get, so this will be the answer for part B, 0.4025. And then what will be the confidence interval? The lower limit is the sample mean minus the margin of error. So the sample mean is 5.6 and the margin of error 0.4025. So let's round to 1 decimal. So 5.2, the lower limit is 5.2. And the upper limit is the sample mean plus the margin of error. So 5.6 plus 0.4025. And that is 6.0 if we round to 1 decimal. So the confidence interval is the range of values from 5.2 to 6.0. Remember, this is another notation to write the confidence interval. So the mean between 5.2 and 6. So there will be questions in the homework where you have to use this interval notation or this one. They're both equivalent and they can be interpreted in the same way.